Okay guys, welcome to last lesson about IP version 4 calculation. Today on the lesson we're gonna consider how distribute the IP address on local area networks. Like if we are working with the host numbers and if we want to see how distribute the IP addresses for the specific networks. So I already wrote here the example. So our example includes, okay, let me explain it in example. So we have 1, 2, 3, 4, 5 networks: network A, network B, network C, network D, network E. And as a given, these numbers are host numbers. It means that on this network A, there can be used for 500 host numbers. It means that 500 usable addresses without counting the network address and broadcast address. And here also in network B it is 250, and network C it is 330, network D it is 30, and network A is 50 host numbers. And the network address is given 10 0 0 0 0, this one. So with the help of this given address and with the help of these given host numbers, we have to find the first useful, last useful network address and broadcast address for each network. So our task is this one. To solve this problem, to solve this task, we have to know. I wrote here like some hints for me, which will help me to calculate faster and easier. And also I wrote here our numbers, which we are using to convert to binary form. So let's start it. Before starting, first thing which we have to do is that write this networks in a increasing form, like from decreasing order, from big to small. So what does it mean? So first we are creating the table, like we are writing hosts, and the hosts will be written in a decreasing form. First will come network A, then it is network C, and the network B, and the network E, and the network D, last one. Okay, and after that we have to find the prefix to calculate. Okay, prefix, and after prefix we have to find network address, network add, and after network address it is first useful address. After first it is second useful address, and the last one is broadcast address. Okay, so you have to create this kind of table for each network. This kind of table will give you clearness to not be confused. So okay, we have created our table, and then let's write our formula, which you have to learn by heart, because this formula will be it's must have. Okay, so first is about 32 minus n is equal to our prefix. And how to find n? You have this kind of formula: 2 power of n minus 2 is equal to host numbers. Okay, so okay, I have already used it. Okay, so learn this formula. Okay, here in a given task we have the host numbers, right? Here we have to put the host numbers. So for the network A, let's 2 power of n minus 2. It's not equal, it is greater or equal. Greater or equal. Okay, greater or equal to host number, it is 500. 2 power of n 498, and will be is equal to, it is here, we have to look here, so n will be 9, and to find the prefix we have to make 32 minus 9 is equal to how much? 23. So prefix of network layer will be 23. The network address is 10, because it's already given here, okay, in the task. Okay, let's find the prefix for next network. It is network C, right? Because it is from bigger to smaller. So it is 2 power of n minus 2 greater or equal to 330. 2 power of n is equal greater or equal to 332, and n is equal to how much here? 9, right? And the prefix also will be 23. Okay, here prefix also 23. It doesn't mean that network address will be same. We have to calculate it, and today we will learn how to do that. So for network B, 2 power of n minus 2 greater than or equal to 250, and 2 power of n is equal to 252, and here we have to look. So it is 252 is here, right? Between this one. You cannot take 8. If you will take 8, you cannot take 9 because it's too much. The closest one is like 8. So and 7 cannot be because 128 is smaller. So here n is equal to 8, and 32 minus 8 will be equal to 24. So prefix here will be 24. Okay, and the network E. Network E, 50. We have to calculate for that. Go to 50, and the 2 power of n is greater than or equal to 52, and n will be is equal to 6, and 32 minus 6 will be 26, right? Here the prefix is 26, and last one D. D is 30, so 2 power of n is equal greater than or equal to 30, and 2 power of n greater or equal to 32, and n here will be 32. It is 5, right? Our condition is greater or equal. In our case it is equal, so we will take 5, and 32 minus 5 will be equal to 27. So the prefix for D will be 27. So we found the prefix for that, and let's calculate starting from network A. We know the prefix and we know the IP network address. We can easily find the broadcast address, first useful and last useful, right? First useful will be like +1, right, for network address, and it is okay, it will be this kind of. Okay, so let me here. So let me change the color. So for to identify second useful, or not second, actually it's last useful. Sorry guys, here I made mistake. Last useful, not second useful. For identify last useful and broadcast address, we have to find first the broadcast address and make -1 from broadcast address, and you will get the last useful. So for that we need to find the location of prefix number 23 in this network. So we know every octet contains 8 bytes, right? So 8 here 16, and 8 here 20. It ends with 24. So we know that our prefix is here, and we have to write here like 10.0.0000000 and 0. Last one we will not open it. Okay, it's this one. So 23, prefix 23, 6, 8, 16, 17, 18, 19, 20, 21, 22, 23. Here we have to put here slash. To find the broadcast address, we are making after slash all zeros to 1. Okay, it means that here we have to write here we are writing the 10.0.1, because here 1, right? After slash it's only 1, so it is this one. And all fourth octet will be full. So when it is full, we have 255, and making -1, and last useful will be here 10, 0, 1, 254. Okay, now we know the network address, first useful, last useful, and broadcast address for the network number, network A. How to find the network address for the next network? It is C. So to do that, you are making +1 to this broadcast address. So the network address will be 10, 0, 2, and 0. So here, look, you are making 1 plus byte. So the mathematical school mathematics, so when you are making +1 to 9, you are here making 0, and 1 is in remainder, and this 1 will be moved to the before this 9, right? And it will be dropped here. So same logic. 255 means it's full. So when you are making 1 plus 1, it becomes 0, and 1 will be moved for the octet which is located forward this one. So here will be 2, here will be 0, and this address will be the network address for the next network. Okay, and for this case we know the for network C we know prefix and network address, and with the help of these given conditions we easily can find our needed. We can easily find easily fill our table. So prefix number 23, we know that it's located in third octet. Okay, let's open it, and we here have 2, and 2 will be in binary form here only 1, right? And we know that our prefix 23 is here. So after the slash, to find the broadcast address will be 1 all of them. Okay, so our broadcast address will be 10, 0, 255. And last useful will be -1 from the broadcast address. And first useful will be +4 network address. Okay. And we are continuing to filling the table, and we are making +1 to find the network address of network B, and the network address will be like this one, because we are making +1 for here, and it becomes 0, and 1 will be moved for the neighbor octet. And the first useful here will be this kind of, and to find the broadcast address and last useful, we use this prefix and this network address. To identify the these addresses, broadcast and last useful, we have to find firstly the location of the prefix 24. So it is 8, 16 and 24. 24 is the last byte of third octet, right? So after the slash we are making all the zeros will become, let's write here, one is more, right? So after the slash all the zeros become 1. So it means that all these zeros will be transferred to 1. So it means that our broadcast address will be 10 0. Here, by the way, you have here 1 here, 4 and 255, and the last useful will be minus from this broadcast address and 254, and we are making +1 to this broadcast address, and we will find the network address for the network E. It is 5 and 0, and we know that the prefix, we have to find this prefix, right? So prefix number 26 is located in a last octet, right? Last octet. So it means that we will open only the last octet in a binary format. So here will be 5, and last octet will be opened like 0 0 0 0 0 0 0 0. So 26, like 24, 25, 26 here. Here we'll put slash, and after slash all the zeros becomes 1 to find the broadcast address. And the broadcast address will be 10 0 5 and 2. All it is 1, right? So let's plus them. 10 20 30 31 31 63 63, and the first useful will be 5 1, and the last useful will be 10 62. To find the network address for D, you are making +1 here for the broadcast address, and you easily identify the network address of the network D. It will be 5 and 64, because it's not full, like it's not 255. So that's why the network address will be this in this format. On here here. Oh, sorry, it's not 60. Oh no, it says 63. Yeah, it is like 10, 20, 30, 62, 63. Okay, 64. Sorry, 25, 26, 27, 28, 29, 30, 31, 30. Okay, good. So first useful will be like 10, 0, 5, 65. And the broadcast address gonna be so we have to find the prefix number 27, right? To do that we have to open it is in this format, in binary format. The network address, we are opening the last octet in binary format, and it will be like this one. So 24, 25, 26, 27 here, and after the slash all will become ones. So if we will translate it and convert it in a decimal format, so here gonna be like this one: 1 0 0 1 1 1 1 1, and it will be equal to so broadcast is gonna be 0 okay 95, and last usable gonna be this one 94. Okay, now you learned how to work with the host numbers, prefix numbers, network address, how to find the network address, first useful, last useful, and broadcast address.